Hello guys, my name is Father Ayola and I'm here to teach us some aspects in statistics. This statistics course is really meant for those of us in financial accounting or those of us doing any course related to finance, business admin. And I hope it's going to be very useful for every one of us. Today I want to treat a topic called measure of central tendency. That's measure of central tendency. Measure of central tendency. And under this topic, we'll be treating issues like the mean, actually it's the arithmetic mean or mean, geometric mean, harmonic mean. Harmonic mean. Then we'll go to the mode and median and the median. So what do we mean by mean or arithmetic mean, which I call AM? What do we understand by the mean? The mean simply is the sum of all values in a data group divided by the number of values. So when you say the sum, when you talk about the sum, you mean the addition of all values in a data group. In computer science, we say in a data set divided by the total number of the values. So, can you see? The sum or addition of all the values in a data group, if it is in computer science, it's called data set, divided by the total number of the values. So what am I trying to say here is that, let's assume we have, let's say, bananas. We have bananas, and let's represent our bananas with the symbol called a B. Let me use a capital B. Now let's assume we have, let's say, 5 bananas. So this banana 1, that's B1, plus banana 2, plus banana 3, plus banana 4, plus banana 5. These are the 5 bananas we have, and the sum, which is the addition of each of the bananas, divided by the total numbers of bananas, B1, B2, B3, B4, B5, that's 5. That is what will give us the arithmetic mean. In a simple word, arithmetic mean simply means the average. So arithmetic mean simply means the average. So what most of us are used to is the symbol x. So let's assume x represents B. X can be any item. You know, B, we use B to represent banana. So x1 is the same thing as B1. So for some of us who might want to be confused, what I'm just trying to say here is x1 plus x2 plus x3 plus x4 plus x5 all over 5. That is what it means. Now, if you look at the definition earlier on, I said the sum or addition of all values in a data group divided by the total number. Total number. Now, this total number, if you bring it out, is represented. So number is represented by a symbol called n. And that total number is the same thing as the 5 we have here. So n, that's 5. So if 5 is up to 6, n will be 6. If 5 is up to 10, n will be 10. So what we now have now is x1 plus x2 plus x3 plus x4 plus x5 all over n. So this is our arithmetic mean. Then better still, to make it a little bit handy, if you look at the definition again, I said the sum or addition. The sum or addition. So when we talk of sum is represented by this symbol. This symbol is called a sigma. And when time you see this symbol, what it means is that you are adding the values, you are adding all the values together. So we can improve on this equation again and say arithmetic mean, AM, is equal to the summation of all values, which is x, over the total number of value, which is n. And if you remember, I used bananas earlier, so you can say the summation of all bananas over n. So please don't get confused with this. Just stick with what you recognize. And if you are a little bit confused, you can pause the video, go back and take a look at where you've missed out. So this is it. Now, arithmetic mean also is represented by a symbol, mean symbol. So when you see this, you know we are talking of the arithmetic mean. So arithmetic mean again is equal to summation x over n. So this is our final equation. Now this equation that I've just done is normally for ungrouped data. Ungrouped data. So ungrouped data, single individual data, x1, x2, x3, x4, x5 over n. But let's assume we have class intervals. In our next topic, I will quickly treat class intervals. But let's just assume you have data like 10 is to 20, or 11 is to 20, or you have 5 is to 10, or you have a 6 to 10. The formula will be slightly different. The formula will change a little bit because now we are talking of group data. We are talking of a group data. And when you find a situation like this, don't be scared. All you just need to do is to modify the formula. We'll just modify the formula a little bit. That's all. We'll modify the formula a little bit. So how do we do that? It's very, very simple. It's very, very simple. Now we'll now bring in what is called a frequency. Now, what do we understand by frequency? For some of our guys working in the broadcast industry, those guys working at the local or international airports, or some of our friends working with the telecoms company, they will understand the word frequency. But let me just break it down to a normal language. Frequency is the number of times something occurs. Is the degree at which something occurs. Sometimes you can say it's the number of times an item appears. So when we say what's the frequency of the disaster, or when you say what's the frequency of the outcome, what you just want to know is the number of times it occurs or it appears. Okay, let's go ahead. Now, frequency is the number of times an item occurs. So we have intervals like this. So what we mean is that, let's assume we have 1, 2, 2, 3, 3, 3, 3, 9, 9, 9, 9, 5, 5. Let's say this is 8, 8, 8, 7, 7. Now we have these numbers here. We have this 1, 2, 2, 3, 3, 9, 9, 9, 5, 5, 8, 8, 8, 7, 7. Now, what we need to do is to group these individual numbers into intervals. We need to group them. Now, once we group them, now look at it. It starts from 1, and the lowest number is 1. The highest number is 9. So, how many times does 1 occur? 1 occurs once. How many times does 2 occur? 2 occurs 1, 2, twice. How many times does 3 occur? 3 occurs 3 times. How many times does, there's no 4, how many times does 5 occur? 5 occurs twice. So, this is what we are going to do. This is 1, this is 2, this is 3, this is 5. Five occurs twice, sorry. What's the next number to 5? I think that is 7. 7. How many times does 7 occur? 7 occurs twice. 7 occurs twice. Then, how many, after 7 we have 8. How many times does 8 occur? 8 occurs 3 times. So 8 occurs 3 times. Then 9. How many times does 9 occur? 1, 2, 3, 4. 9 occurs 4 times. 9 occurs 4 times. So here now, what it means is that this is the number of items, so this is n. And here is the frequency of time they appear or they occur. So this is frequency. So this n means the numbers, the items. So n occur once, the frequency is 1. N which is 2 occurs twice. N which is 3 occurs 3 times. N which is 5 occurs twice. N which is 7 occurs twice also. N which is 8 occurs 3 times. n, which is 9, occurs 4 times. So if you look at it now, here is 1, 2 appears twice, 3 appears 4 times. So you have to correct this, because we need to be very careful of our data collection. It might affect, or it will affect, our final answer. So 3 occurs 4 times, 9 also occurs 4 times, 5 occurs twice, 8 occurs thrice, 7 occurs twice. So can you see 1 appears 1, 2 appears twice, 3 appears 4 times, 5 appears twice, 7 appears twice, and goes like that. So this is how to determine a frequency. Now that you've seen the level of frequency, let's now go to the formula. Earlier on, under the ungroup, we got this formula. Ungrouped gave us this formula. That is arithmetic mean, which is this, equals summation of bananas over n, and I said banana is the same thing as our x, which represents numbers of items, over n. That is for ungrouped. Now for a group data, the formula is quite interesting, but it is simple. Now n, we say n is the number of items. So n here is also equals to frequency. And better still, n, when we say the n is the total number of items. So what does n represent? We say, okay, the sum, arithmetic mean means the sum, addition of all values in a data group divided by the total number. Total number is our n right now of value. So total number here, we are now talking of total frequency. So we have summation, which you also know that is a sum. N is the same thing as your total frequency. N is the same thing as your total frequency, but it does not end there. So if we now want to get the arithmetic mean of a group data, I will now say arithmetic mean equals summation x over summation x fx over summation f. That's the summation of the that's the summation of the frequency multiplied by the numbers of items over the sigma f, which is summation of the frequency. That's the total number of frequency. It can also go like this: summation x over summation, over n. So can you see the similarities between the two? So if you want to get the arithmetic mean of a group data, is summation f of x over summation f. We will still come around to solve some questions, some illustrations, but let's just flow along. Now, harmonic mean is quite trickish. What harmonic mean does is used to calculate the average average. So harmonic mean used to calculate the average Now take note of this: average of the ratios. Take note of this. So the average of the reciprocal values. Take note of this. We have average, ratio, and reciprocal. What the formula simply does is that it brings the n up. The n that has always been used to staying below as a denominator, the n now becomes the head, now becomes the numerator, now becomes the boss. Now the n comes here, and to make it worse again, it relegates x to the final bottom. So reciprocal, that's one reciprocal of the values. You know that our values are x. So reciprocal is 1 over x, 1 plus 1 over x2 plus, if you have more x there, up to where the x ends, xn. This is the formula for an harmonic mean. So what it means is that you turn everything upside down over itself. So n, numbers of value, all over the reciprocal of x. This is the formula for an harmonic mean. Now, let us go advert break.
Welcome to 4 Unit International. We are into fumigation and pest control services, borehole engineering and drilling services, solar panel and inverter installation. For our fumigation and pest control service, we deal with any kind of pests that must have been bothering you, whether it's rats, rodents, insects, mosquitoes, termites, bed bugs, etc. We are here at your service. Contact us at 0817 53 29 453. Our drilling and engineering servicing. We do borehole drilling, geophysics services, and construction piling drilling. For you to have water in your house, you need water, and water is life. So for your drilling and borehole service, if you need to dig a borehole in your apartment, in your compound, just give us a call and we'll be at your service. Our solar panel and inverter installation is top notch. Within 24 hours, we'll be at your house to do a power regulation check, and we'll give you the best power and the estimate for your living room. Just get in touch with us and we'll be at your service. Our contacts are 0803 72 60 244, 0817 532 9453. Now, let us treat the mode and the median. But before I go on, let us quickly treat the geometric mean. Geometric. Now, usually, most of us some of you guys, or those of you who are experienced in mathematics and science, will understand immediately what geometry means. And for those of you in geology or areas of architecture and things like that,
you immediately understand when you see anything called geo, you understand that it has to do with something related to a territory or something related to an area. But we are not going into that. This is not mathematics, and this is not also core statistics. This is business mathematics or financial mathematics. So when we have geometric, we mean GM. Let me say GM, geometric mean, GM mean. What we mean is that we are talking of the nth root of the product of a value. So nth root of the product of a value. That is the geometric mean. So when we say nth root, obviously we know what root means. This symbol represents anything called root. Now they say they now say the nth root. So once we hear the nth root, what it means is that the n will be here. So this is the nth root. Nth root. So let me put th here. Nth root. Can you see? So when you at back of your head, once they say something is a root is being identified with this symbol here already. Then they now said the nth of it, the nth root. So n will hang at this angle here. It will be hooked there. So this is the nth root. Now we now have the nth root. So the next thing in the formula is nth root of the product of the value. So our value, which you understand that our value is is x. Value is x. So values can also be bananas, if you remember what I mean. Bananas can be plantain, can be oranges. But let's stick to what we all know universally, which is x. So the nth root of the values. So we already have a root, we have the nth. Now we now need the values, and they said it's the product of those values. So the product of those values. So when we talk of product, we mean multiplication. So x here, x1 multiplied. I'll make the multiplication. Let me use asterisk, just the same way we do in computer science. So this x1, we have x2 multiplied by x3, and so on up to the last x multiplied by x n. So this is the nth root. x1, x2, x3 up to xn. I just use this asterisk to represent multiplication. You can use your normal x sign. I just want a situation where this will be unique from our values. That's why I use the symbol we normally use in programming, computer programming, to symbolize it. So now we have the nth root of the product of the values, which is x1 multiplied by x2 multiplied by x3. Now this is how you get your geometric mean. In our lesson 2, I will now treat each individual jobs, questions, illustrations, to give you a broader understanding of what we are doing. Now let's quickly go to mode. The mode is simply the value which occur most frequently. So we have a mode, the values that occurs most frequently. So Guess what? Frequency, well, is left to you, but it's similar. They are almost the same. But here, what it means now is that they say the values that occurs most frequently. Now let's go back to the illustration I did earlier. Now we have some values here. This is 1, 2, 2, 3, 3, 3, 3, 9, 9, 9, 9, 5, 5, 8, 8, 8, 7, 7. Now let's assume I added another 9 here. Now, what will now be our mode? We say the value that appears most frequently. Now, 1 appears once here. So now our 9 is going to now appear 5 times. So 9 appears 5 times. So when you check the remaining data, you find that 9 is the most value that appear. So this will now be our mode. Okay, so 9 is now the mode. 9, because it's the value that appears most frequently. Now this, you can do this when you have values which are ungrouped. But what happens if you have values which are grouped? Now for group data, there are two things you can either do. You can either solve it graphically or by formula. Take note of this. This question normally comes out in your OBJ. They will ask you, in which ways, how many ways, or which ways can you solve your mode, a group data? You can either solve your group data graphically or by formula, excuse me. Now graph will come under graph, and that should be in our maybe like our 4th class or 5th class. But now this formula is what we are going to treat right now. Now if you want to write the formula of the mode, we have what is called, we have something that looks like this. I know this is what normally scares a lot of students, the fear of the assimilation of the formula. Yes, I can guarantee you that I was once there also, but you don't need to fear anymore. What you need to do is to confront it head on. But I'm here to make it look a little bit simpler and easier for you. Now, look at this formula, which is kind of scary to you, most of you. In fact, it's this formula that has made some of you write your exam multiple times. But today it will end. Now, you'll be wondering, what does this mean? What does this mean? Once you see this dreaded formula, you're like, what is all this? Especially for those of you who came from the commercial class and you're not really grounded in mathematics, or came from the hard class and you want to kind of change your careers. Probably you found yourself working in a financial institution or an insurance company, and based on the level of promotion in your company, you need a financial certificate. I understand what you are going through, but just look at what I'm about to do. Now you see something like this, which you've always been seeing, and you wonder, what does this mean? Now the L, what the L means is called the lower class boundary of the mode or modal class. The lower class. Mind you, we are treating group data here. Treating group data. So it's different from what we did earlier for the modal class. The lower class boundary. Now, when we talk of class boundaries, I'll quickly treat class boundary. Okay, let me quickly treat. Okay, I'll treat the class boundary after I conclude the mode and the mean. In fact, it comes in our next class, which is lesson 2. So let's just take it easy right now. This is lower class boundary of the modal class. Are we okay? Good. Now we see this triangle symbol. Mind you, you can use any symbol for it. What I would like to do is, I also want to create my own symbol. Is MF. This is MF. What does this triangle symbol mean? Now, this triangle symbol, sometimes I call it delta. A delta symbol. Now, what does it mean? It means the modal class frequency minus frequency of the class before the modal class. Now, this might not sound interesting right now because I've not yet used any illustration to resolve this problem. But just try and understand what each part of this thing is talking about. So, say MF is a modal frequency. So there is modal frequency minus, say, the frequency of the class before the modal class. Frequency of the class before the modal class. So modal frequency, you'll understand what modal frequency means. Now we have delta 2, which also is modal frequency minus frequency of